All right, recording. This is section 10.6. Today we are solving rational equations. So when we first started last night, we were dealing with expressions. And so when we have an expression such as like 2 over x plus 3 over x plus 2, okay, basically we multiply by a fancy 1, right, on both sides, right? Here, we don't use our fancy ones when we have equations. We clear our fractions. We use the idea of equivalency by clearing our fractions. What is the least common denominator here? 2x. A 2x. So I can take the whole fraction and multiply by 2x, right? Now, when I solve equations, I clear fractions. When I simplify expressions, I multiply by that fancy 1. Does everybody understand the difference? Yes. We were doing this back when we had it back before in chapter 3. We were clearing fractions. Multiply by a number so we can get rid of the denominator. Okay, so let's first talk about, before we even do this, what is the restriction for a fraction? We have a rule about fractions, and what is that?
It can't be over 0.
What can't be?
The denominator can't be 0.
Can't be 0. You can't end up with a 0 in the denominator. So in this case, for this problem, the restriction is x is not allowed to equal 0. Now, I said to you, what is the least common denominator, and what could I multiply all terms by so that I could clear my entire denominator? A 2x. Now, I line it up with the numerator, and basically what this means, I'm going to do an extra step right now. I don't usually write out this many steps. I think you can do it mentally, but I'm going to write it out the first time. And that would be like, I'll be multiplying 2x times 3 over x, okay? And then I have a plus, I'm multiplying 2x times 1 over 2, okay? Equals 2x times 5 over x. Now you can put that over 1 if you want. And notice that I'm distributing it to all terms, both sides. Why am I allowed to do this? Because this is all about equivalency. And an equation is still in balance as long as you do the same thing to both sides, all terms. It's a property of equality. So when I distribute here, notice my x's cross cancel and we're left with what? 6. When I cross cancel here, my 2's cross cancel and I'm left with x. And when I cross cancel here, my x's cross cancel and we're left with 10. Okay, so now I'm subtracting 6 and x is equal to 4. Okay, and does that work with the restriction?
Yeah.
Okay, so with equations, we clear. We don't multiply by a fancy 1. I don't need to do, the only reason when I had a expression like 2 over x plus 3 over x plus 2, the only reason why we did the fancy 1, right, multiplied everything by the same numerator and denominator, was because I needed to rename this so that I could add them together. I'm not changing its value by multiplying by a fancy 1. Does that make sense to you guys?
No.
So with expressions, we multiply by that fancy 1, which would be, in this case,
X plus 2.
uh,
Wait, it's 2x because the denominator
No, it would be, in this case, if I were multiplying by the fancy one, I'm multiplying by x plus 2 over x plus 2. I'm not changing its value. Here, I'm multiplying by x over x, and then we're going to have a common denominator. Whereas here, I'm changing every term's value equally on the left side. Does everybody see that?
Yes.
Who said no? So, whereas here, on this side, notice I multiplied each term by 2x. I increased each value. I didn't multiply by 1. I increased the value by 2x because I multiplied each term by 2x. Does that make sense? I can't multiply by just 2x here. It will change the value of the fraction.
Why can't we make both of the, why can't we add 3 over x and 1 half first?
Because they're an unlike denominator, it's easier to just clear the fraction.
That you could do that?
I don't want you to. I want you to clear the fraction. I taught you it in chapter 3. I want you to be able to. Now, when I'm doing this, I don't write that 2x every time. I'm going to show you. I distribute. Okay? Cross cancel, I'm left with 2 times 3 is 6. When I distribute, am I just distributing a 2 or the 2x? 2x. So then the 2's cross cancel, I'm left with the x plus 1 is x. X times positive 1 is x. And then when I multiply by 2x, the x's cancel and I'm left with equals 10. Subtract the 6, x equals 4.
Okay, I understand that, but how'd you...
I'm going to pause it. So the question is, how did I know to multiply by 2x? I looked at what's in the denominator. And so what I'm multiplying by what I could divide that out evenly. And I could make my denominator disappear. Let's try another. Okay? What would be my least common denominator, Bryce? I need a number or a quantity. 10a. I'm multiplying all terms by 10a. Okay? By the way, what's my restriction?
X cannot equal 0.
In this case, yes. A cannot equal 0.
And it can't equal negative. Oh, no, it can't.
What?
Why is it 10a?
Because I need, what can I do? Multiply it by so that I can divide an A, a 2, and a 5.
But then why in the first one didn't we do 2x squared?
Why do I need 2x squared?
Because there was 2 x's in the
Okay.
first one and...
Okay? So take a minute. Try and solve this one on your own. We've got A is equal. A cannot equal 0. Okay? Pause the recording. Okay, let's check our work. We said the restriction A cannot equal 0. My least common denominator for all 3 terms would be a 10a. So when I distribute here, the A cross cancels and I'm left with 30. When I distribute here, the 2 cross cancels and we're left with I'm left with a 5 and an A. Was it a 5? Yeah, 5a. And then when I distribute a 10a here, I'm left with a 2a times 4 is 8a. Subtract the 5a. 30 equals 3a. Divide by 3.
30 or 3a?
And a is equal to 10.
How is that 30?
Because 10 times 3 is...
Oh, I see.
Okay? So, it's just going back to chapter 3 when we were clearing fractions. Okay, try the next one on your own. Pause the recording. Don't forget to start with your restriction. Okay, what is my restriction? Alan?
0.
X cannot equal 0. You need to say x cannot equal 0, whatever it is. And that's only when there's a variable in the denominator, right? So what is my least common denominator? What am I multiplying by, Alex? 3x, 12x, good. Otherwise, 3x, I can't clear the 12. So when I multiply 12x times the first term, what does it simplify to, David?
It simplifies to 4 times 2 is 8.
Which is 8, good. So this simplifies to 4 times 2. I'm left with 4 times 2, okay? And then I'm going to distribute again. And the 12 is going to cross cancel, and I'm left with x times minus 1 is x. And then I'm distributing again, and my x is cross cancel, and we're left with 60. Subtract the 8, negative x equals 52. I'm not allowed to be left, it's not isolated, it's left with negative 1, so I have to clear that, I have to multiply both sides by negative 1, and I get x equals negative 52.
Or divide.
Or divide, yes.
So I did this, but just to like make it more clear, when you get the 12x, that's the least common factor.
Okay, let's try something. Let's say I took, let's try this. Here's the thing, when you're factoring and it's an expression, you have to factor completely and you want to go with least common. But if it's an equation, I could potentially multiply by 24x, right? Now I'm going to be left with 8 times 2 is 16. 12 goes twice, 2x minus 2x, and 24x. I'm left with 5 times 4 is 20, carry the 2, 5, it's 10, 12. So subtract the 16. I get negative 2x equals 104. Divide by negative 2. It's just, if you don't take the least common, it's just bigger numbers. Right?
No.
I still ended up with the same number. Okay?
It was a 128. I don't
It's 120. Okay? So you just end up with bigger numbers if you don't pull least common. Whereas when you're expressions, you have to do least common denominator. Yeah.
We have to write restriction if x cannot be equal to 0.
You just have to write, yeah, restriction x cannot, for any fraction that has a variable.
But we don't have variable in the denominator.
No, you don't need to write that. All right, so now this is something, it looks very different, but it's very similar to something like this. Okay, what's that called? Yes.
Inequality? I said proportion.
It's a proportion. So the same way we do proportions, we can solve this. This will be 3x, and this will be 10. And then we divide by 3, and x is equal to 10/3. Okay? We can solve this problem the same way. Yes?
I don't know what that is.
That's called a proportion. Okay? It was part of Math 7. We studied, and we could do cross products. So anytime you have a fraction equals a fraction, we can do something called cross products. Multiply here. And I'm going to show you why that works in a minute. Okay? What is my restriction here this time? Annabella?
Negative 2?
X cannot equal negative 2 because the negative 2 will give you a 0 in the denominator.
We have to write restriction.
Yes.
But no.
Yes. Okay. So now we are multiplying. We can do a cross product. Only if it's a fraction equals a fraction can we use our cross product. So I'm doing this, Alex. Ready? I can multiply the denominator times the opposite numerator. So it's 3 times x plus 2. And this one would be equals 6 times 7, right? So that's 42 equals 3x plus 6. Subtract the 6. from both sides. That's 36 equals 3x. The inverse is to divide by 3, and x equals 12. Okay, questions? Questions? Yes.
So there's only like a monomial of x in the denominator. X is always cannot be 0.
Yeah, if it's a monomial and it's x. Okay? And that works for my restriction. Okay? Okay. Another method when I get fraction equals fraction, another method would be to clear the denominator. What is the least common denominator?
3x.
No, it's not 3x. No.
3 times the quantity of x minus 5.
3, and we need the times the quantity of x minus 5. Don't multiply it out. 3 times the quantity of x minus 5. I can clear it. By the way, what's my restriction?
X cannot equal 5.
Good. So when I distribute here, I'm here. 3 times x minus 7. When I distribute here, we can cross-cancel the 3's, and I'm left with x equals 2 times x minus 5. So I can do the same thing we've been doing. And notice, cross products. Isn't this end up being 3 times x minus 7? Look here. If I were to have done 3 times x minus, it's still here. So it works out the same. Doing your cross products or clearing the denominator, one method or the other. Let's finish it up. Now I'm going to multiply by, I'm going to multiply it out. 3x minus 21 equals 2x minus 10. Subtract the 2x from both sides. I'm adding 21 to both sides. X is equal to 11. Let's try our next problem. Tell me about the restriction. Go.
N cannot equal 0.
Good. Okay. What would I multiply all terms by to clear the fraction? Alex.
You can multiply by n.
By n. So my restriction is n cannot equal 0, and I'm multiplying everything by n. Okay, so I distribute. N times n is? Good. N times 5 over n is?
-5.
Good. And then n times 4 equals 4n. Now, when you're doing properties of equality, I like to see the n on both sides. Okay? Both sides of the equation. Now what?
Now you add.
No? Julio?
You factor?
Not yet. It's not in trinomial form.
You subtract -4 and
We subtract 4n, not negative 4n. We subtract 4n, not negative 4n. When you say subtract negative, that's a double negative. Always move your numbers, your terms, to the side to keep n squared positive. Keep your quadratic positive and put it in standard form. Now, what multiplies to -5? What multiplies to -5 and adds to -4? Go. 1 and -5. Good. N plus 1 and minus 5. Set them both equal to 0. And we get n equals -1 and n equals +5. Do they work with the restrictions?
Yes, they do.
Yeah.
So my solutions go into a solution set.
So n can equal.
-1 or n can equal 5. If you try them back in, which this is an easy enough problem, like -1 minus 5 over -1, right? -1 minus 5 over -1 equals 4. Doesn't that make a positive? -1. So you can just try your number.
It's just like a bunch of different steps to
We're just clearing. We're recording. Okay. What's my least common? Well, first of all, what are my restrictions? Somebody I haven't heard from? Ash?
0
And?
and 1. Wait. 0 and 2. Negative 2.
How would, okay, so -2 plus 1, does that give me a 0? No. She's going to fix it. Don't worry about it. What?
Negative 1.
Good. 0 and -1 are my restrictions. Okay? Now, if I were going to clear the denominators, what am I multiplying by? How about Matthew?
Plus 1.
Will that clear the x?
No.
No. You cannot take a piece of a binomial. What is the least common denominator? It's Matthew's turn.
X.
That will clear the x. How am I going to clear the x plus 1? Okay, how am I clearing it? What's the least common denominator here? You said I needed an x to clear the x. What do I need to clear the x plus 1?
1. X times x plus 1.
X times x plus 1. Okay? Now, when I distribute, the x clears, and I'm left with 3 times x plus 1. Now I'm going to do it again. When I distribute here, the x plus 1 cancels, and I'm left with plus 4x. I'm going to do it a third time. Okay, when I distribute here, nothing gets canceled, and I'm left with 2 times x plus 1. Okay, now we distribute. 3x plus 3 plus 4x equals 2x squared plus 2x. Move everything over. Minus 3x minus 7x, right? Minus 4x here. Sorry. Minus 3x minus 4x. I'm just zeroing these out. You guys with me that these two make 7x on this side? And then I'm going to subtract 3 and subtract 3. So now I'm left with equals 2x squared minus 5x minus 3. Now we have to do our lead coefficient factoring. 2 times -3 is -6 and -5. What is it?
Negative.
It's negative.
So it would be x plus 1 times x minus 6, but we have to divide by 2. And so this factors to 2x plus 1 times x minus 3. Now this one's easy. X minus 3 equals 0. 2x plus 1 equals 0. So here x equals 3, and 2x plus 1 equals 0. Subtract 1. 2x equals -1. Divide by 2. X equals -1 over 2. So you have two solutions. Do they work with my restrictions?
No. How does 1/2 go into 3 over negative?
I asked you, does it work with my restrictions?
Oh, yeah.
It absolutely does. -1/2 and 3 are good solutions.
Wait, why is it negative?
Because I subtracted 1. I'm doing inverse operations. Okay? I'm going to, maybe this will be a little bit clearer. Okay, now everybody say extraneous solution. Extraneous solution. Okay, so what are my solutions here? I mean, what are my restrictions here? restrictions. Shivam?
1.
And? Oh, just 1. So x cannot equal 1. I want to hear you say x cannot equal 1 when I ask restriction. So I can do my cross products. X times the quantity of x minus 1. 2 times the quantity of x minus 1. And then I distribute it. We get x squared minus x equals negative 2x. I'm sorry, equals 2x minus 2. Which way am I moving everything? To the left or to the right?
To the left.
To the left. Subtract 2x, add 2. Add 2. Now, what multiplies to 2 and adds to 3?
Oh,
Negative
simple. Negative 2 and negative 1.
Negative 2 and 1. And so then we get x plus 1.
That doesn't negative 1.
No, it's negative 1.
X, good, sorry. X minus 1, yeah. X minus 2 equals 0. So here, x is going to equal 1, or x will equal 2. But what?
And then you draw the solution.
Okay.
But it can't equal.
It can't equal 1 because, so this is what an extraneous solution is. An extraneous solution is a solution that works for the equation, but it doesn't work for the fraction rule. Okay? It doesn't work for the rule in mathematics. Right? Our restriction is 1, so in your answer column, you're only going to write for me 2. Unless I say to you, what is it, if there is an extraneous solution, what is it?
Oh, so an extraneous solution doesn't mean you cross it out, it just means you.
Yeah, you don't use it. You don't use it, you don't talk about it unless asked about it.
Okay, got it.
Okay, let's try the next one.
So if you ask for the extraneous solution, then we'll give it.
Then you would give it to me. I can't stop right now. Thank you. All right, next one. What are my restrictions?
Negative 3.
Go.
X cannot equal negative 3.
Good. Okay, this time I'm going to multiply. We'll multiply x times the quantity of x plus 3. And I'm going to multiply negative 3 times the quantity of x plus 3. And then I get x squared plus 3x equals negative 3x minus 9. I'm going to move it all over. I'm going to add 9. How do I factor that? What multiplies to 9 and adds to 6? X plus 3 times x plus 3.
X plus 3 squared.
Shh. X plus 3 squared. Okay? And so what? I only have one solution. There aren't 2 negative 3's. You don't need to write that answer twice. But that is our restriction. So what do we say?
There's a non-valid answer.
What do we say? No solution. You're right, it's a non-valid answer. We say no solution. Because negative 3 is an extraneous solution. It works for the math, but it doesn't work for the rules of fractions. All right, let's try one more. Shh. Now, this one, before we can clear our denominator, we have to factor. So we get x squared. How does that factor in the first one?
So it goes x plus 2x.
We're finishing. What does it do?
X plus 2, x minus 2.
Okay, I need you guys to talk quickly. If you can't talk quickly, don't raise your hand. Okay, now what am I multiply? What am I going to multiply? First of all, what are my restrictions?
2 and negative 2.
What?
2 and negative
2 and negative 2.
And then
Hold on. Okay, what am I clearing it by? What do I multiply, Annabella? X plus 2 times x minus 2. When we distribute the first time, what's left? What's left?
0. Wait, no. 1.
When-
Over 1. X squared over 1.
When I distribute, what's left?
X squared.
Thank you. When I distribute here, What is left? I cross cancel the x plus 2. And what's left is plus x minus 2. When I distribute here, okay, the x minus 2 is, and I'm left with equals 3 times x plus 2. So now I'm going to distribute. Okay? And then I'm going to set it equal to 0. Subtract 3x, subtract 6. I'm factoring x is equal to 4 or negative 2. So what's the solution?
4.
4 only, because negative 2 is what? Extraneous.
Extraneous.
Okay, all right, and I believe that's it. We're out.
Oh my god, I need to go to